Assalamualaikum. My name is Ahmad Adnan bin Abu Bakar. My matrix number is AA190659. I am from section 7 and now I'm going to talk about the introduction for this program-based learning. So when performing our program-based learning, we know that we should show our greatest gratitude to the respected person willing to give help and guideline to the task. We are really grateful because we managed to complete our Engineering Mathematics 2 program-based learning within the time given by our Encik Zul Afiq bin Sazali. This task cannot be completed without the effort of the group members, so this assignment refers to the chapter 4, First Equipment Application. In this chapter, there are two forms of application in which general differentiation questions are applied, namely population growth and Newton's law of cooling, will be discussed. So four of us managed to discuss this assignment via Google Meet and WhatsApp group because we cannot have physical meeting during this pandemic. So finally, thanks to Encik Zul Afiq bin Sazali and the group members for the effort given to complete this assignment. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. This is Muhammad Imran bin Kumawdi. Text number AA190612. We are from Group 8 for PBL Engineering. So for the population growth question, we have chosen question number 1. And question sounds like the number of bacteria in the liquid culture is observed to grow at rate proportional to the number of cells present. At the beginning of the experiment, there are 10,000 cells, and after 3 hours, there are 500,000 cells. Find how many will there after 1 day of it. If the unlimited growth continues and the doubling time of the bacteria. So for popular table, facts that we can get from the question is there are 10,000 cells at the beginning. Second one is after 3 hours, the bacteria itself grow to 500,000. The last one is bacteria immunity affected grow to the number of cells present. Okay, let's move on to the ideas. So the ideas is to bring out the information from the question, such as the information about the number of cells, about the times taken. So we are using the formula given for the chapter 4 on the population growth. So next we find the growth bacteria after 1 day, which is 24 hours in terms of time, and calculate the doubling time of bacteria. Okay, the learning issue that we get from the question is based on how to find the growth rate of bacteria, how many bacteria that can grow in 1 day, the growth rate between initial hours and after 3 hours, and lastly is the doubling time of the bacteria itself. So for this question, the resource that we need to solve the problem is via internet itself, engineering maths module, video tutorial given by our lecturer, and example question that we have been practicing. Okay, so that's all for basically the table for the question number 1. So we'll move on to the next member to explain more about the solution for the question 1 on the population growth.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad Fikri bin Muhammad Zabri, matrix number AA190036, and I'm from section 8. So today I'm going to explain to you about our solution in question 1, which is the question is the number of bacteria in a liquid culture is observed to grow at a rate proportional to the number of cells present. At the beginning of the experiment, there are 10,000 cells, and after 3 hours there are 500,000 cells. So it asks us to find how many will there after 1 day of growth if this unlimited growth continues. And the second one is find the doubling time of the bacteria. Okay, so for the first one, how many will there after 1 day of growth? Okay, so as we can see that for the beginning there are 10,000 cells, and after 3 hours they are increasing, which is increasing to 500. Okay, so here is the solution. So as we can see that for the beginning, which is we don't calculate the amount of time of the beginning, which is 10,000, and after 3 hours we got 500,000. Okay, so what do we do here? What we did here is that we put C as cells for 0 time, which is 10,000, and C in the bracket of T, which is 10,000 e to the power of k and t. So to find the k, which is the proportional constant, first of all we put the equation for the 0 time and the 3 hour time, which is C3 equals to 10,000 e k, the t is 3, equals to 500. Okay, so which we can clear is that for the cell for 3 hours we got 500,000, and the formula is here, 10,000 e k and 3. So the first thing that we done is we divided both sides with 10,000, which is the initial value, and then we got e the power of 3k equals to 50. And then if we wanted to discard or substitute the e, we have to put ln in front of e and also 50. So we can cancel off the e, and then we got 3k equals to ln 50. So if you wanted to get k only, what we do is we bring 3 to the right side. We got ln 50 divided by 3, and we got the proportional constant, which is 1.3 per hour. So the amount of cells that will grow for 1 day, which is 24 hours, we put the formula right here, and we change the t to 24, which is 1 day we have 24 hours. So C24 equals to 10,000 e, the k is 1.3 and the t is 24, which is 24 hours. So we got the growth for 1 day is 3.548 minus 10 power of 17. And for the next question, the doubling time of the bacteria. Okay, so for the doubling time of the bacteria, we know that doubling time equals to t. So 10,000 e k t, capital T, equals to 20,000. So we divided both sides with 10,000, which we got e k t equals to 2. So as I said, that if we wanted to discard the e, we have to put the n for both sides, and e is gone. So that leaves kt equals to ln 2. So if we wanted to find 2, we bring k to the right side, which is ln 2 divided by k, and we got and we put the a value of ln2 and k, which is ln2 is 0.69 and k is 1.3. So we divided 0.69 divided by 1.3. So we got the doubling time is 0.533 hours. So that is all from me. Thank you.
My name is Mama Iman bin Marwin. Number matrix AA192073. Now we continue to the filler table, section B, question 5. So the problem statement is a thermometer which has been at the reading of 70 Fahrenheit inside the house is placed outside where the air temperature is 10 Fahrenheit. 3 minutes later, it is found that the thermometer reading is 25 Fahrenheit. Find the thermometer reading after 6 minutes. So we got the 4 categories, which first, facts. The first one is thermometer reading inside the house is 70 Fahrenheit. So the second one is thermometer is placed outside where the air temperature is 10 Fahrenheit. And the last one is thermometer reading is 25 Fahrenheit after 3 minutes later. So the ideas is temperatures inside and outside the house vary. The second one is the wind blowing outside lowers the temperature of the thermometer. And the last one is the density of water in the air is very high outside the house. So we go to the next category, which is learning issue. The first one is how the difference of temperature affect the time rate of change of temperature. And the second one is what is the reading of the temperature after 6 minutes. And the resources that needed is the first one, internet. The second one, science textbook, science, and the third one, science guide. And the fourth one is encyclopedia. Assalamualaikum. We go to the next topic, which is solution of case study for question 5, section B. According to the Newton's law of cooling, the time rate of change of temperature is proportional to the temperature difference. So we get the equation which dt over dt equal minus k in bracket T minus Ts. Ts is the temperature of air, which is 10 Fahrenheit. So we substitute the value and will become like this. And then after that we need to exchange the dt with t minus 10, and then we will become this. dt over t minus 10, it will become natural law in bracket t minus 10, and minus k multiplied by dt will become minus kt plus natural log c. After that we need to simplify, and it will become t equal 10 plus c exponent and the power of minus kt. After that, when t equal of 0 and the big T equal 70 Fahrenheit, and we substitute the value. 70 equal 10 plus c, and it will become c equal 60. Hence, t equal 10 plus 60 exponent to the power minus kt. When t equal 3 minutes, and the bigger T equal 25 Fahrenheit, and we substitute the value before. 25 equal 10 plus 60 exponent to the power of minus 3k, and we simplify the equation, and it will become e to the power of minus k equal 1 over 4 to the power of 1 over 3. Thus, t equal 10 plus 60 multiplied by 1 over 4 to the power of t over 3. So after 6 minutes, t so it will become t equal 6. So we substitute the value t equal 10 plus 60 multiplied by 1 over 4 to the power of 2, and then we simplify this equation. It will become t equal 13.75 Fahrenheit. So this is for our answer for this question. Thank you. That's all.
Hi, my name is Muhammad Nur Afiq bin Muhammad Hairi, number metric AA191054. Okay, let me tell about the conclusion of this chapter. For the conclusion of this chapter, which is differential equation, as well as being able to solve first order differential equation. We also find out that we are able to communicate mathematical idea and apply our knowledge and understanding to mathematics in everyday life into some particular application. We be able to first organize differential equation that can be solved by each of the three methods: direction integration, separation of variables, and integrating factor method, and to use the appropriate method to solve them. Second, use an initial condition to find a particular solution of a differential equation given a general solution. Third, check a solution of a differential equation in explicit or implicit form by substituting it into the differential equation. Fourth, understand the term exponential growth or decay, proportionate growth rate, and doubling or halving time when applied to population model, and the term exponential decay constant, and half-life when applied to radioactivity. And last, solve problem involving exponential growth and decay. Okay, that's all from me.